So, do many of you here own 3D printers? Does anyone own a 3D printer? It's actually the same in the UK, nobody ever owns one. But there are many out there in the wild, and 3D printers can do very many things. The cheapest 3D printers can print something simple like this, like a bottle top. So that's your usual cheap printer. But there are other printers that wouldn't fit here. There are even printers that could print this whole building. So I saw one of those in China. Very large printer, it prints concrete, and they printed towns in China, whole entire towns. We can even print human bodies with 3D printers. So we could, for instance, print our professors here. We can print organs. We can do all sorts of things with 3D printers that you probably don't realise. We can even print DNA. So you can do almost anything with a 3D printer. So this is my research area, and I look at the law of 3D printing, and I also look at some of the development of the technologies to enable regulation of 3D printing. So I'm going to talk to you about a project that we've been running over the last few years, which is based in the UK and in China. And which involved all these bodies. The funding was from the Arts and Humanities Research Council, from the Newton Fund, and also the Ningbo Science and Technology Bureau. And this is actually one of the first, amazingly, one of the first joint projects funded by the Chinese government and the UK government. So it was known because of that. So I'm going to initially play a video for you, which will just explain a little bit about the project and show you some footage of 3D printing, so you can see it in action, and then I shall talk a little bit more about it. If it works. Printing is a highly innovative technology. It enables individuals to be able to print products far more easily than ever before, and it challenges traditional methods of manufacturing. The project that we are running is sponsored by the Arts and Humanities Research Council. This project is being run also with staff from the University of Exeter, Sussex, Durham, University of Nottingham-in-Bow, and the Chinese University and Law. We also have another company called S&M Manufacturing.
We collect data through interviews, industrial placements, and workshops. More specifically, we arrange 2 face-off interviews with more than 30 Chinese 3D printing companies. We will also organize 2 workshops in which professionals from the industry, academia, and government officials will attend to share their opinions and experience.
The principle of the proposed licensing platform is to enable to automatically license 3D printed products. Examples of the technology concerned include RFID and watermarking. This will enable 3D printed products to be trackable and traceable, providing new business opportunities.
3D printing technology, also known as additive manufacturing, is changing the way we manufacture and produce things, from small items such as personalized jewelry to engineering components and toolings and even body parts. The 3D printing process starts with data preparation. The 3D model of the object that we want to print can be created in the traditional 3D modeling software. After that, using the 3D printing professional software, the 3D model is sliced into successive thin layers. The information of each layer is stored in a digital file. The file is then transferred onto a 3D printer, where the object we want is printed out layer by layer. As the digital file can be shared easily across the internet, and they're usually not protected, it becomes a challenge on how to protect the intellectual property rights of the design. So, additive manufacturing technologies provide opportunities for industry in product development. As metal additive manufacturing machines providers, we provide solutions for our customer making functional parts which are difficult and costly to be built in the past. Certainly, our customer would like to make sure that their products is being protected by a proper and secure IP policy, which can be easily identify their contributions. This project will be a good start and a good leading directions for the future development.
In China, 3D printing is at an early stage of development, and it is hoped that the proposed system will facilitate growth.
The NHRC 3D printing licensing in China project aims to engage academic research with the growing needs of the 3D printing industry. I believe the interviews we have been doing will contribute to future policy making.
The disseminated result of this project we will share with researchers and findings via workshops, reports, and academic outlets. Additionally, the public can access this by articles on local newspapers and online channels such as blog and videos.
So there you go. So there's a very short video in systems, a little bit similar to that which you see on services like YouTube or Spotify or Netflix. And this is what's known as a form of watermarking. And it enables you to be able to identify content and know how people are using the content, whether or not they copy things. So you'll be familiar with a watermark already. So for instance, in a banknote, which is a British banknote here, you have a watermark, which you might see with lights, in the middle of it, which demonstrates that it's a genuine banknote. And if you have any of you ever tried photocopying banknotes? Nobody wants to go back through it, but you'll find you can't easily photocopy banknotes because photocopiers are designed to recognise the watermark in the banknote, and they won't let you photocopy them. So I don't know if that necessarily works here, but in the UK that's required by law. So you have similar technology to that on videos on YouTube, on Spotify and Netflix. So it's already quite widely used. And what we're doing is taking that technology and applying it to 3D prints. So for instance, with this bottle top, what we do is we put a watermark in this that would allow you to track and trace the use of it, or if you want to prevent people making a copy. So this is the sort of digital equivalent. This is how it works. So this is from a competition that was known as Cicada 3301. You may have seen it in the press, so nobody really knows who started this competition. It had clues placed all over the world, and the purpose of it was to basically try and find intelligent people. And so the competition began with this. It's a digital watermark. And so this just looks like text. It doesn't look like written text on a piece of paper. So it says our first clue is hidden within this image. First, it will lead you on to verify the blah, 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 blah. So what this indicated to you, if you're clever, you would realise that maybe something is hidden in the image and you can actually see it here. Normally you can't, but the lighting is bright. If you change the brightness of that image, this is what's revealed. Which seems quite straightforward, that's just like a paper watermark, isn't it? But you could also load up this image in Microsoft Word or Microsoft Notepad. And then you would have this, which was a clue. So there is some text hidden in the image. And that's essentially what we do with digital watermarks. We hide text in files to identify them. So you can see there is some text that someone's inserted into the image at the top there. And so that was just simply to enable people to then go and find a particular book, and then they could go on and read the book and find another clue and so on and so forth. But we're just concerned with the digital watermark. So that is what a digital watermark in part will look like. Okay? So we are basically inserting this sort of thing into a 3D print. Okay? So it would look a little bit like this. So this is hexadecimal. This is the way in which you can insert the information and you can identify and find it. So whenever you use a computer, this is what's passing through the memory of the computer or whatever you're using. So this sort of watermarking system is actually used already in general copyright. So obviously you've got YouTube, Spotify, and these services. It's also used by the UK Copyright Lab, which is a sort of private but government-sponsored organisation that helps enforce copyright in the UK. And they will put these watermarks into images to enable you to license the images legally instead of just downloading them without permission. So we already have this sort of watermarking operation, just not for 3D printing. So that's what we look at, putting it into 3D printing. So we had many workshops and events over China. We interviewed 30 companies. We ended up with 100 companies involved in total, which is most of the 3D printing companies in China, to enable us to develop this software. Some of this turned out to be quite popular, so there's a funny story with this. That one of these workshops we had recorded and it was put up online. It was at the same time as Donald Trump's inauguration ceremony. And more people watched our conference than actually who were at Donald Trump's inauguration ceremony. So that was quite funny. So we actually had millions and millions of people watch that. So it's been obviously of interest to people because it's a bit like science fiction. So how do we actually do this? So this is what I'm going to explain to you. How do we actually achieve what we're doing? Well, we're taking some existing research, just academic research, into 3D printing, looking at how one might watermark 3D prints. And we basically take this and we combine this and put it in our licensing context. So this is one such example of how it could occur, using something called histogram-based circular shift coding structures, which works like that. So if you have something like this bottle top, when you print it, there will be subtle shifts to the surface of it that you might not be able to see with the human eye, but which a scanner or a phone, say, or a photograph would reveal, so you will know what happens. So you can insert the watermark into the software, which is what this is, into the software. When the thing prints, the watermark will be on the surface or inside the print. And this is where it gets clever, because you might have a watermark in this, and then I might take a photograph of it with my phone, and I'll upload the photograph online. I can search for the same watermark that was put into this online. And remember, 3D printing, you can have a different watermark for every single print. So, for instance, every single bottle of water in this room could have a different watermark on it, and I'll be able to find out exactly which bottles went where, and who used which bottles, and I'll be able to know all this from the photographs online. And so people in the future, 10 years down the line, may take a photograph of this, and I'll still be able to search for the image of it. Okay, so that's how this works. So it enables licensing, because that may sound horrible in some ways, but in other ways it means you don't need to purchase anything because you can make information from the use of it. So this could mean anything that's 3D printed, you don't need to pay for. You can just make money from information about use. Like Microsoft do with Windows 10. So that's one technology. So we take some of this. I'm not going to tell you everything because we've got a patent pending, so I can't explain everything, but I'll tell you a little bit. So this is another method which we combine it with. So again, with the print, you can have, if this is sideways onto this bottle top, say, you can put little marks on the surface like you get on the vinyl record, or audio CD, anything like that. And again, that can be identifiable by scanners or what have you. So what we do is combine some of these technologies together. And so this is another way in which it looks. This is more complicated than it really is. So again, this just helps to make it identifiable individually as to what the object is and how it's used. So we apply this and this and all those various bits and pieces, which is really just inserting an equation into the surface of an object or inside the structure of an object into this. So this is called an STL file. This is the thing that a printer prints with. So this is like a Microsoft Word document, but for a 3D printed object. So We changed this. We changed this file. This file format is very basic actually. It's just X, Y, Z points like you have on a map. So we take this and we obviously make it more complicated by inserting this individualized data into it so it's possible to track and trace the object. So this is the sort of process that we have. So it looks a little bit complex, but essentially it's a little bit like this. So we're taking one simple shape and we're making it slightly more complex in ways that can be usable by computers through a variety of formats. And so this is the example that we used at one of our conferences. So this is some technology that we developed. To you right now, they all look absolutely identical, but they're not. So you can take photographs of these different objects, and as we demonstrated at our conference, you have all these objects, take a photograph of it, search for it online using the original watermark, and you'll know exactly how it's being used. And then you also know people take photographs of the photograph. If somebody photocopies the photograph and then uploads it again, you can still find the watermark. Or people try and edit it, it's still reasonably successful because we're combining together a number of different technologies. So we have these various stages. We take an equation, we apply it to an object, and then we apply it to the final print so that everything is still discoverable. So that's the technology side of it. That's the technology that we've elected as patent pending in China. So what I want to look at very quickly then is about what the legal protection is, because there's more uses to this watermark than simply that which I've mentioned. Oh, I'm turning off. The computer's had enough. It didn't like the equations. I think it might have just run out of battery. Run out of battery. I can continue talking so we stay on time. So, we have protection under copyright law, under specific provisions. We've got this from international law, from Article 12 of the World Copyright Treaty in 1996, and that's implemented into laws of many different countries. So in the United States, in Section 1202 of the DMCA, 1998, or Section 296ZG of the CDPA, 1988. So there are all these different provisions, and they specifically protect what they call copyright management information, which we realise in practice can include watermarks. The trouble with this is that it includes, not only includes, we think, copyright content. Now, obviously, this could be a little bit problematic. Now, something like a water bottle top, you know, you might think, well, it doesn't really matter if that's got specific legal protection or not. But there are other areas where it's very, very useful to have this protection. So, for example, we can have, for instance, I was just saying, we could print our professors. But if we print our professors, we want to know that our professors will be well. So, for example, we can 3D print livers, but we want to know that the liver is operating properly. We can use a watermark exactly the same as what I've just been talking to you about in the liver. And then we'll know whether or not, I can't hear anything out there. So we can look at the liver and decide whether or not the liver is collapsing by looking at that watermark. But livers don't have copyright. It's got nothing to do with copyright. So there's no legal protection on that. So we might say maybe we should have specific legal protection outside the field of just copyright. Okay. So I shall stop there. I did think this is deliberate because I had many slides to go. Did you pull the power? But I hope you enjoyed that. Thank you very much. And if you've got any questions, please ask. So thank you very much.